Ever wonder what happens to your meal after you eat it, or how you have the energy to play soccer, take tests, and go about your day? Your body is constantly involved in processes that break down all the components of your meal, including proteins, fats, and sugars. Aerobic metabolism, in particular, breaks down sugars in order to produce molecules called ATP, which is the main energy source your body uses to help you finish a day's work. Amongst these metabolic processes, there are several steps that aid in the production of ATP, including glycolysis, PDC, the TCA cycle, and the electron transport chain. In this video, we will be covering the process of PDC, or the pyruvate dehydrogenase complex. PDC is essentially the traffic director between glycolysis and the TCA cycle.
In glycolysis, sugars are broken down into a molecule called pyruvate. This molecule can be converted into acetyl-CoA by PDC, which can be used in other metabolic pathways to produce even more energy or create fat to be used later when your body is in a caloric deficit. If you think of PDC as a traffic light, things run smoothly when it was green. It uses the product of glycolysis, pyruvate, to make acetyl-CoA, which can be used to make and other enzymes to make energy.
PDC has three enzymes, E1, E2, and E3. Each one of them gets a helper. E1 has helper TPP, E2 has a swimming arm, and E3 has helper FAD.
Once the meal you have eaten is metabolized by glycolysis, you're one step closer to getting your energy. The product of glycolysis, called pyruvate, must then be processed by the enzymes that make up PDC. The three enzymes that were mentioned before each play an important role in the conversion of pyruvate into acetyl-CoA, the end product of the PDC. E1 is the first enzyme that pyruvate must encounter. By utilizing a helper molecule, E1 is able to remove CO2, the gas you exhale, from pyruvate and then transfer it to the E2 enzyme. E2 then creates acetyl-CoA by moving what is left of pyruvate onto a molecule called CoA. In order for E2 to be able to continue doing this process, the portion of it that was split apart earlier must be fixed.
The citric acid cycle turns acetyl-CoA into ATP through several reactions, and this energy is then used by your body for everyday activities. Your body can recognize when you have too much or too little sugar in your blood and will take steps to regulate how PDC is functioning. If you have not eaten for a long time, you will not have enough sugar, and PDC will slow down the consumption of sugar by blocking the reaction with acetyl-CoA or by adding a phosphate group to PDC, which will inactivate the complex. If you have just eaten, PDC will speed up to break down all the sugar you just ate. If PDC is not working properly, or if you were not born with functioning PDCs, your body will not have enough energy to work how it is supposed to. This can lead to several diseases and various symptoms throughout the body, like muscle weakness, confusion, and lack of coordination.
Okay, now you learned about how body makes energy ATP after having a delicious meal and the consequence if one of the steps, such as PDC, doesn't work properly during the process. Again, having a functional PDC is very important for our health.
Created using Powtoon.